This video is in continuation of my last video. Here I discuss briefly on fumigation, lofting and trapping. As you know, the behavior of plume emitted from an elevated source such as smokestack depends on the degree of instability of the atmosphere and the prevailing wind turbulence. The commonly encountered plume behaviors are looping, coning, and fanning, and they are observed under conditions of uniform lapse rate. You can see here for looping, this is a strong instability, and coning is near neutral stability, and fanning is obviously strong inversion is there. So the following plume behaviors are observed when lapse rate changes from stable to unstable. One is fumigation, lofting and trapping. Today I discuss them one by one. Fumigation. At clear nights or in the early morning, a radiation inversion extends from the surface to well above the height of the smokestack. When the sun comes up, the surface air starts warming and the radiation inversion is gradually breaking up. However, the air above the chimney is still stable due to the presence of inversion. So a stable layer lies above the chimney and an unstable layer, air layer, lies below the chimney. So this is a combination of fanning above chimney and looping is below the chimney takes place. So the I just put dry adiabatic lapse rate to understand better this figure. Now the properties. So vertical motions are confined to the region below the stable air, that is near surface. So vertical mixing is confined to this region, this unstable region, and unstable air causes pollution to mix downwards and towards the ground in large rump, which is very near of the source. The pollution concentration is high near the source, and sometimes surface concentration goes up to dangerously high level. So and but this condition usually lasts for only short duration, only for 30 minutes. So this is fortunate for us. Fumigation is favored by clean sky, light wind, and in summer season. And taller smoke is preferred at it extends upward to the stable layer. So if the stack is this much, so it produces a fanning plume that does not mix downward toward the ground. So the lofting is after sunset, the ground cool rapidly and radiation inversion starts reappearing. So an unstable layer of uh, air lies above the release point of the plume and a stable layer lies below the stack. When pollutants are emitted above the inversion layer, they are dispersed vigorously in the upward direction, since the top of the inversion layer here acts as a barrier to movement of pollutants towards down, producing a uh, lofting smoke plume. This condition is opposite of fumigation. So I put dry adiabatic slabs right here to understand this figure better. So the vertical mixing is uninhibited in the region of unstable layer of air lies above the stack height. So here vertical mixing is uninhibited, but the downward mixing is greatly restricted by the inversion stable layer lies above below the stack. So lofting helps keep the pollution high above the ground, reducing the exposure to the people living downwards. So downward concentration, pollution concentration is least in this condition. So lofting is the most favorable plume time as far as ground level concentration are concerned. Most commonly occur at late afternoon to early evening, especially after sunset. More common in spring and fall with clean skies, and lofting is favored when low wind speed near the surface and moderate wind speed aloft. The last is trapping. The trap plume occurs when plume effluent is caught between two inversion layers. So the diffusion of effluent is severely restricted to the unstable layer between two stable regions. So the pollution are sandwiched between these two stable layers. So though structurally it is one is like is fusion of both lofting and fumigation. It is lofting and this is fumigation, but it leads to long lasting localized pollution, because as trapping is long lasting localized, whereas in case of lofting, plume rise and escaped aloft, and in case of fumigation it lasts for very short period of time. But here trapping is long lasting localized pollution. So though structurally this is the fusion of two, lofting and fumigation, but with concentration, with respect to the concentration of pollution, it is different. So I put here the dry adiabatic lab state to understand this picture better. So downward mixing is inhibited by the inversion stable layer lies below the stack. So this inversion stable layer restricted downward mixing, and the vertical mixing is also restricted by the inversion layer above the small stack height. So this stable layer inhibits the vertical mixing. So the only vertical motion is confined to the unstable layer between these two stable region. So trapping may also be associated with subsidence inversion lasting for several days, where almost emissions are trapped below the inversion layers and creating one of the worst pollution situations. So occurs especially in winter and early spring or fall. Long nights, clear skies, weak sun, this is the condition. Allows strong, and this condition allows strong inversion and sometimes subsidence inversion aloft. So, and another thing is weak wind prevent the vertical and horizontal mixing. So allowing pollutant to accumulate in the trapped layer. So this is the worst. So if I rank the plume behavior with respect to ground pollution level concentration, so trapping is the worst, whereas lofting is the best. And if I just rank one by one, so lofting is best, then fanning, coning, looping, fumigation, and trapping. So you may refer these books for further reading. Thank you for watching this video.